Hello everyone, here is Jiayi and welcome to my homework 10 presentation. This presentation is for homework 10 and question 1. In this question, we need to explain my understanding about this processes, the 7. Okay, now let's focus on the first one and one by one. The first one is the Poisson process. So the Poisson process is, the definition is this one. It's the probability of n t1 to t2 equal to k is equal to this is a Poisson distribution form. This formula is mean between t1 and t2 in this time interval t1 to t2, the probability of n equal to k is this. So t, the tau is the interval and lambda tau is the mean of n in such interval. So let's take an example. Let's assume 5 bus arrive at the stop in 1 hour for average. So tau is 1 hour and lambda tau is 5. The Poisson process means in next 1 hour, what is the probability of k bus arrive at the stop? Let's see. We want to get the probability of 3 bus maybe in next 1 hour. So we put the k is equal to 3 and 1 is tau. Yeah, the lambda tau is still 5. So we can get a probability. That is the Poisson process. So this process focuses on the interval, and if the interval t1, t2, and tx, ty, maybe t3, t4 are not overlapping, then they must be independent. For this property, we can assuming that the buses are independent. So the arriving number will also be independent in different interval on statistic meaning. And we can also get the first order probability masses is this. This is from time 0 to time t, which can be seen with the definition. Just change the t1 equal to 0 and t2 is t, right? So based on this, the expectation of xt is lambda t, and which is corresponding with the meaning of the Poisson process. Between 0 to t, there is the expectation or average or mean bus arriving as lambda t, right? And we can also get the R and C, which is the autocorrelative and covariant, and we can get this. We can focus we can notify that there is a main of T1 and T2, which means the RS means the relation between the different T, right? So this is mean the relation between 0 to T1 and 0 to T2 is only about the overlapping part. The overlapping part is the last one, T1 or T2, the last one. So the 0 to T1 or 0 to T2, which one is last one, which one is the overlapping part. So we just choose this. All right. And the second question is Poisson increment process. And this is just this process is used to describe the increment. Yeah, increment. So we just use the later one minus the present one and divided by the gap. So it's definition. It's similar like this. And we can get the probability from this to get this, and also get the expectation is lambda. It is corresponding to our understanding, right? The expectation of the Poisson process is lambda t, and we just use the increment, so we can get it's only lambda. But here the expression is lambda can reflect the increment of Poisson process, which is lambda t in interval t. And we can also get the R and C like this. The third problem is the Poisson impulse. Impulse is more is upper level on the first and second. It one increment process, the sigma is near to 0. It is the impulse on time. So we can focus on, or we can see this when the sigma is equal to 0 and this is really near to this one. So it's just the derivative, right? So the zt is equal to the derivative of xt with respect to t. Alright, we can, based on this, get the expectation R and C. The expectation also lambda. And we need to know when the zt minus lambda, it become white noise in the real world, because we can see this, the expectation of this noise is 0. That's right. We know the average of the white noise in the real world to some signal wave is 0. But the R is lambda impulse of T1, T2. Okay, the fourth is semi-random telegraph signal. We know that the Poisson process is this, but the semi-random telegraph signal is when the k is even xt equal to 1, and k is odd, xt equal to -1. This is actually used to describe the two-status signal wave, like this, the positive, negative, positive, negative, right? Uh, so by the definition, we can get all this, the probability, expectation, R, and C. We should notice that the probability of uh, two status is not equal. Uh, when the t near to not zero, sorry, there is uh, infinity, right? Positive infinity. The uh, they are near to half because actually it is start with the positive, so uh, we can't neglect it uh, at very beginnings, but when it comes to infinity, it can be neglected. So it will be half when t is near to infinity. And the expectation also is like this. It is not a zero, uh, but when it near the infinity, sorry, the expectation near to zero. Also, the R and C, we can see the same thing. And come to the fifth, the random telegraph signal. Actually, I think the YT, the random telegraph signal, is just combine the status one start, uh, the positive status start a semi-random telegraph signal with the negative status start signal. It just combine these two. Yeah, that yt is equal to a multiply with xt, and the probability of xa equal to positive or negative is half. So we can get this is really same as intuition. It combines them two, so it can uh, neglect, not neglect, just uh, decline the influence from the start. So they all become to half, and the expectation becomes to zero. Like no start bias signal. And the sixth is random work. Random work is just like we think about the person on binary uh, direction and work, like toss a fair coin. Uh, you can go uh, you can go a step and back a step. Uh, each is half probability. So we can get the definition that x can be this, with s is step, and k is one direction, maybe positive direction work times, and n is total times, so right. It's positive steps minus negative steps as the uh, distance, final distance. And we can also get the expectation is zero, right? It's just like the binary distribution comes to normal distribution. The mean is zero. All right. the RNC is really uh, same like the point one. It just uh, need overlapping parts. And now is the seventh. Seventh is winner process, where the XT is random work and WT winner process is the XT when the t near to 0 and n near to uh, infinity, s squared divided by t is near the alpha. So we can get the density function, expectation, and RNC. It's selected to describe the uh, Brownian motion, first and random motion, just like uh, the normal is statistic or the large scale of binary distribution. The winner process is also the same to random work. Right. Okay, that's all my understanding about these processes. Thanks for watching.